Hello, welcome to the second semester of chemistry. This first video lecture is about what's called the kinetic molecular theory of matter. And basically what this is this is just a way that science explains the different states that we see in matter, like solid, liquid, gas, in terms of what the particles of the matter are doing. So when we're done with this little video lecture here today, you should basically be able to talk about three things that the particles are doing. You should be able to talk about the arrangement of the particles, you should be able to talk about the motion of the particles, and you should really be able to talk about the amount of kinetic energy that the particles have in the three different states of matter. So just a quick review, I just said kinetic energy, and kinetic is in the title of this theory, kinetic molecular theory. Just remember that kinetic energy is the energy of moving objects. So kinetic energy, I'm going to abbreviate it KE. It's the energy of moving objects. So it's the energy of moving objects. The particles that make up matter are always moving. They might be moving in different ways, but they are always moving. The faster that something's moving, the more velocity that it has, the more kinetic energy that it has. So when I talk about the kinetic energy of moving objects, we're basically talking about how fast the particles that make up the matter are moving. And just kind of an interesting thing that we're going to be learning a lot more about, the kinetic energy of the particles that some matter has basically equals the temperature of that matter. That's just a little aside. It's not the focus of this lecture, but that's definitely something we're going to be learning a lot about in this class. So let's just go ahead and flop down our three states of matter here. We've got solid, and then we'll do liquid. Oops, that's a Q. Derp. Liquid. And then, of course, we've got gas. Okay, we'll start with the solid, and I think what I'll talk about first is something that you might be really familiar with, and that's the arrangement of the particles. Basically, how far apart are they? In a solid, the particles are very close together. I mean, they're basically touching. Again, with the spelling. All right. And what's really important about solid particles is that they are locked in place. So what that means about solid particles is that they're usually kind of trapped. They can't really move around very well. So if you think about kind of like the particles that's in some kind of a lattice of a crystal or something like that, they're kind of stuck in place. And what they can do is they can just kind of wiggle or vibrate where they're at, back and forth. And so when we talk about the kinetic energy of the particles of a solid, eventually, what we're talking about is how rapidly they're kind of vibrating in place. They can't really go anywhere else. But if you look at the particles of a liquid, they're still close together. But they're free to move. So when you're looking at the particles of a liquid, they might be close together, but they can freely move around past each other. So if this particle might be over here right now, but it actually might slide and move through all of these other particles, it's able to do that. This particle right here might move down through all of these particles, and it's free to do that. They're pretty much always going to be touching, but they're not locked in place like the solid particles. They're free to move around. And then when we look at the gas particles, they are very far apart. And because they're so far apart, I mean, they basically, the only time they ever encounter each other is when they collide, when they hit each other. So they're very far apart, and they're not only are they free to move, but they're moving very, very fast in a straight line. Of course, unless they hit something. So if you imagine the particles of a solid, of a gas, there's going to be a lot fewer of them because they're very far apart compared to the other two states, and they're basically moving very, very fast in a straight line. And they'll move very, very fast in a straight line unless they hit another particle, and then they're going to kind of bounce off from each other. And so that's kind of how the motion of these three states differ. The particles of these three states differ. So just to review, solid, very close together. The particles are very close together, whether they're molecules or atoms, and they're locked in place. So basically all they're doing is wiggling. They just kind of wiggle, vibration. So they vibrate. The liquid particles are again close together, but they're free to move around, and so they just kind of randomly move past each other. And then the gas particles, they're very, very far apart, and they move very fast in straight lines unless they hit something, and then they'll bounce and ricochet off, kind of like pool balls would do. So that's the motion of these particles, and the distance between them. So solid particles very close together, liquid particles are close together, and gas particles are very far apart. And then the motion would be described here, like solid particles are locked in place, but they're still free to vibrate, whereas liquid particles, they can move around past each other, and gas particles move very, very fast, usually in a straight line. And so then that leads us to the kinetic energy. And so you can probably guess what's going on with the kinetic energy here. The kinetic energy of solids is the lowest, and then the kinetic energy of gases is the highest, and the kinetic energy of liquids is somewhere in the middle. And that should make sense because, again, we said that kinetic energy is tied to temperature. So if you think about, if you don't change the type of matter, that would mean that as the temperature increases, the kinetic energy of the particle increases, and you would expect the phases to shift from solid to liquid to gas. And so like if you think about water, if it's cold enough, it will start out as solid. We call that ice. And then as the particles gain kinetic energy, eventually they're going to start to be free to move past each other, and at that point it will become a liquid. And then eventually they'll get so much kinetic energy that they can just fly away from each other and start moving around in straight lines, and at that point the water would be a gas. And this is the pattern that you see with all matter in these three states. So make sure that before you try the mastery quiz, you know in your head how close together the particles are, how the particles are moving, and how much kinetic energy the particles have. If you have those things stuck in your noggin, you're probably ready to take the quiz. So that's the end of this very first lecture, video lecture of the second semester. If you have any questions, as always, feel free to ask in class. Thanks for watching.